Hello, this is a great pleasure of having this presentation on responsible research and scientific integrity for the UFE 20, for the UFE 2030 meeting. And let me begin by introducing the our own group, the Synopsys Meta Research Group, which is unique in the sense that it applies research methodologies to the study of practices of university practices themselves. So in some sense, it incorporates scientific knowledge to study research policy and optimize the practices of universities themselves. Apologies for the stop. I have a little bit of a sound issue. Can you please confirm that you can hear my presentation clearly, and then I will review.
Yes, we can hear you clearly, and we can see the presentation as well.
Right. So the Synopsys group is consisting of several tasks. So it serves as a meta research center at the University of Cyprus. Meta research is an emerging research field that involves different disciplines and different research centers and interdisciplinary working groups in different countries. Again, with the purpose of studying the practices of science itself. One of our main interests is to bring together other scholars of the University of Cyprus interested in research policy, interested in understanding the practices of academia, and basically create a forum and a group that allows fruitful discussions to take place and interdisciplinary research to be conducted, but also the university policy itself to be informed. And we are also trying to generate meaningful policy advice. So this kind of coalitions and this kind of initiatives like UFE, they have this special features of outlining the importance of young research universities in Europe and how they can be special and they can be pioneers in new approaches to research policy. So once more, welcome to our guests and especially the junior people interested in research practices and integrity. So this is part, of course, of the UFE training series on responsible research practices, and this is the domain that we're going to be touching upon. Importantly, we will speak about what might go wrong in science and which are the approaches that have been discussed in order to improve things. Basically, when we all start as researchers, we start a little bit in the idealistic view that research is the search, that science is the search of truth, that it is an impassionate process of the discovery. And then the more we work and we experience actual research, we realize that science is, of course, as we should have known in the first place, a human institution with its advantages and disadvantages, and therefore we should be careful and treat it in the same way as other institutions with weaknesses and potential policies to ameliorate these. So today we will focus on the problematic of credibility crisis in research, the antidote to this, which are good practices involving transparency and leading to better reproducibility, and also we will also focus on an interactive approach. I hope my sound issue does not prove very problematic there, where we will illustrate the particular ideas about problematic versus good practices with real examples. And again, the idea is to be a sort of self-contained material and tools that can be applied practically. So, in particular, in terms of the learning objectives, after the end of this meeting, you're expected to be able to understand the replication crisis in science and its implications, to learn about specific practical open science tools. For instance, the new developments in pre-registration and in open code sharing, often in real time. You should be able to apply responsible metrics. Responsible metrics are closely related to the problem of the quality of science, the reproducibility crisis, and so on and so forth, because essentially the incentive of scientists, how they are rewarded, affects their behavior, especially from an economics perspective. Incentives are the most important element in economic behavior. So how metrics are used to assess the quality of research is of fundamental importance for good science. And that is where the concept of responsible metrics goes in. For example, as applied by the COARA initiative. And related to that, going a little bit deeper into the concept of responsible research evaluation, we will also mention the what narratives these are and how they can be used to showcase diverse contributions. These measures such as narrative CVs are important, especially today that modern tools allow us to reduce the cost of producing high quality narratives of our contributions and essentially explaining the research journey of the scientists rather than bullet points with individual publications. And finally, you should be able to recognize and address integrity challenges in research. And of course, the issue of integrity is closely related to almost all of the aspects that we have discussed so far and the ultimate quality of research being produced by science. So when I was involved in this topic of the of meta-science, my first contact, if you wish, was an article at the New Yorker, which had this particular image, which talks about the truth wearing off. So about 15 years ago to 20 years ago, there was an initiation of a discussion about the potential replication crisis, in the sense that it seemed that subsequent studies that started from some often famous findings did not seem to find similar results. In other words, the initial results did not seem to be replicable. And this pattern in the following years, since the 2010s, has exhibited itself across different disciplines. And the most systematic way to show the problem was large replication initiatives that brought together collaborators in different universities, often a very large number, that conducted a great number of replications in a coordinated way. That was the best way to actually bring things together and show clearly the picture, which was that in important social science disciplines such as psychology, about 1/3 of studies replicated. So which means that for starting researchers from UPE, let's say in the domain of psychology or social science, you should be contemplating on the underlying reasons why, although as scientists we are supposed to produce robust and generalizable knowledge, we can often find ourselves in these difficulties. So we're talking about the work of established, very distinguished, sometimes researchers who were conducting the initial studies, but nevertheless, the large initiatives in replication showed that these results were not replicable. And along more or less along these lines, and at the same time, similar initiatives happened in economics, one led by Colin Kammerer and his team, which showed that economics fared best. There are many reasons why one would consider one discipline to be more replicable than the other. We don't have time to go into that depth. But in experimental economics, the reproducibility rate was better. And then, of course, the poster child of the discussion about the reproducibility crisis was biomedicine. It started all this. So already since 2012, there were some famous reproducibility initiatives to replicate very important findings in cancer research with very low reproducibility rates. And oftentimes, it was pharmaceutical companies that conducted these replications and showed the often disappointing reproducibility rates for published preclinical studies. So now that we set the stage and showed that things do not go always in a rosy and expected way in science, but there can be problems, we can go a little bit more deeper and think about the underlying reasons for these problems. So for starting researchers, for junior researchers, it is important to think and contemplate about the driving factors of non-reproducible research. The general discussion has taken place across several general categories, including methodological flexibility. This roughly means that you're allowed to make conclusions on the basis of analysis, often statistical analysis, that takes place a lot of different forms. So the more experienced one becomes with statistical analysis, the more we realize that there are very many different ways to analyze a given data set. And oftentimes, this can lead to different conclusions. This is the concept of methodological flexibility. And it is problematic because oftentimes, as researchers, we know, if you wish, what is the desirable outcome in terms of publication prospects, which of course is problematic. Similarly, the lack of transparency of the methods is, if you wish, interacting with methodological flexibility, exacerbating things. And then all these play a role together with statistical noise, which is, if you wish, a natural reason why results would fail to be replicable. And ultimately, in some rare cases, there might be even research misbehavior in terms of conscious problematic reporting of the evidence because of incentives to find the results in a certain, in a particular direction. And also milder forms of research misbehavior relate to the lack of transparency. Those are referred to as questionable research practices, whereas research misbehavior is more related to conscious fraud. Okay, at the same time, at the institutional level, the macro level, there are factors such as publication bias. These are not directly related to the practices of individual researchers, but about systemic incentives in the publication process. It's not just individual researchers who are interested in getting interesting results, but of course, it is the publishers themselves and the editors themselves that are interested to declare interesting discoveries in terms of their readability, their scientific impact. And as a result, the publication bias refers to a phenomenon whereby what actually ends up being published is only a biased sample of the actual research, biased in the way that significant results are overrepresented. In other words, findings that declare a new discovery, some association between variables important for scientific knowledge, this kind of discoveries are often heavily overrepresented in the literature. But the failure to confirm an association or a discovery, that is much less interesting, if you wish, but it's not less important for science, and this bias creates important problems in seeing the totality of what we should be knowing about different variables and the relationships in nature. Now, p-hacking is a sort of more concrete notion related to the notion of methodological flexibility. The more we gain experience with statistics, the more we realize that in practically every scientific empirical article, there is a large number of statistical tests. There is a large number of interesting variables. So usually there is like a general interesting relationship that we want to examine. But how we operationalize showing that this relationship holds often takes place in a complex way, using different variables, different dependent variables, different independent variables even. So there are very many ways that you can show evidence corroborating the fundamental relationship. So oftentimes, what can take place is that there is a choice of those statistical tests that seem to work, that seem to show a relationship which is interesting and most likely publishable, and hiding the potentially great number of statistical tests that was not supporting this relationship. This is the concept of p-hacking, and of course it's very closely related to the notion of transparency and the lack of transparency and methodological flexibility. Because obviously, if there is enough transparency, then you cannot selectively choose which statistical tests to present in the final publication. And then hacking is related in the sense of the initial study being not sufficiently driven by theory. So it is important as scientists that we advance theory in our discoveries. Essentially, theory is the tool by which we learn about truths in nature. Science essentially is theory, mechanisms of our understanding. So if we don't start with strong enough theory, we might resort to strategies such as hacking or hypothesizing after the results are known. Then you don't have true hypotheses. After observing a large number of statistical tests, you might decide that it seems that there is some pattern in the data, so you post hoc theorize what might be causing what, and you might even present this as a hypothesis that you had in the first place, which is, of course, is disingenuous. So again, researcher degrees of freedom is related to most of these issues at the individual level, and lack of transparency, as you mentioned. Of course, this is a fundamental problem, and this is why meta-research, meta-science as a new domain focuses so much on this. And those important consequences are, of course, the wasted resources for society of investing and building on false findings. For instance, the development of non-efficacious drugs. It has been estimated that this amount is extremely high, at the rate of 28 billion per year, according to an estimation. There is also more fundamental long-run erosion of the public trust in science. Of course, we are living in an era where, unfortunately, we see a lot of aspects and a lot of appearances of this problematic phenomenon, the erosion of public trust in science. Often populist movements utilize this for their own interests. And of course, these things are translated inevitably delayed process in addressing societal problems. So issues that could have been resolved faster if knowledge was able to accumulate better without these biases now are not addressed as they should. And then you have the implication for career impacts. Oftentimes we observe scandals in research, non-reproducible findings, scandals about research misbehavior, and these reverberate on the scientific careers of juniors and senior researchers. Oftentimes there are, as we shall go into this later, there are trade-offs and there are difficult decisions that need to be made within a scientific team. And this is very important for career development and in terms of ethical choices. Actually, within Synopsys, we have economic theory models that try to examine these different incentives of junior and senior researchers and how the responsibility for research misbehavior can be optimally allocated in order to optimally solve this problem of genuine revelation in cases of research misbehavior by other parts of a given group. So now, in this part, we will speak about more in depth about meta-research, studying research itself. So the founding document, if you wish, of the domain of meta-research was the very famous publication by John P. Ioannidis in 2005 with a very provocative title, Why Most Published Research Findings Are False. So this came rather suddenly into a scientific reality and society that was not alert to such an important problem of lack of reproducibility. And John wanted to make this a strong statement. Actually, Ioannidis and his team, along with other researchers, for several years before 2005, were conducting and advancing the domain of meta-analysis to show how knowledge accumulates, and they had gathered quite substantial evidence about the problems there. But society and science at large had not acknowledged the issue. So therefore, this was sort of a manifesto rather than a pure scientific article in 2005, and it initiated the domain of meta-research. But what exactly is meta-research? So this is John Ioannidis, and he, along with others, has defined meta-research as the study of science itself. To be fair, the study of science has been studied for more than 7-8 decades in mainstream research in the domains of philosophy of science, sociology of science, and so on and so forth. However, what is sort of new in this domain of meta-research is the highly interdisciplinary aspect. So now researchers from different disciplines come together to understand the workings of science, and it is also very quantitative. It is closely related to the statistical area of meta-analysis, which are very strong ways in which it diverges from traditional philosophy and sociology of science, but also it is determined as a solution to an important topical phenomenon, which is the credibility crisis in science. So these are characteristics that define it and differentiate it from traditional approaches. So what does meta-researchers study? It studies the different science methodologies, whether they are appropriate, whether they are robust, whether they can be improved. Okay. Similarly, it's not just the method that can cause biases and problems in science, it's also the reporting of the results. We referred to this previously. Selective reporting, p-hacking, empirical examination of the extent of this phenomena, potential remedies, all of those are within the domain of meta-research. Measures of reproducibility, as we saw before, solutions to the problem of reproducibility, interventions, policy interventions to improve them, and of course, research evaluation and assessment. How can we optimally assign rewards in research such that they improve on the problems of bias, non-reproducibility, and so on and so forth, align them better with the underlying objective of scientific discovery of the truth in nature. Okay, and again, as I hinted to before, in those all those domains, empirical methods play a very crucial role. So these are not just generic verbal discussions about how science works, but a much more focused and empirical approach. Okay, and as we mentioned before, we're talking about measuring the degree that problems exist and the possible solutions and interventions. And importantly for junior researchers, it will be important to know that meta-research is a growing field that attracts increasingly the support of funders and international organizations, obviously because of the importance of the waste in public funds that comes from the problem of non-reproducibility. So as a result, there's a great stake for society to improve things and getting it right. And that's why meta-research is strongly supported in Europe and beyond. And that's why we see, and we hope in Synopsys that we have helped there that initiatives that incorporate open science aspects, such as UPE itself, is starting to incorporate research within its domains. And the same with COARA. So there's a large literature in meta-research that provides specific examples of what we said before, problems in science, problematic methods, problematic evaluation, criteria, and so on and so forth. So there's a large number of studies, actually extremely large, within the meta-analysis literature that shows the problematic effect of small sample sizes, especially combined with publication bias. You reach a situation where you have a proliferation of studies with small samples declaring large treatment effects, so large associations between variables in science that are oftentimes very weakly reproducible. Then the recent solutions that have been suggested for these problems include pre-registration. Pre-registration is important. We will get into more depth, but roughly speaking, apologies. If the problem is the researcher degrees of freedom, how a researcher can conduct a large number of statistical tests and then report only a fraction of these tests that seem to be favoring their own objectives in terms of what is interesting and publishable, then what we should be doing is tying our hands, essentially, saying beforehand what kind of test we will be reporting, exactly which kind of hypothesis we have, even in case of experimental research, how we're going to be generating new data, and how exactly our studies will be conducted, with what sample size, and so on and so forth. So pre-registration is one of the most important and popular suggested remedies to the problem of research reproducibility, and it has been found relatively recently by strong research teams, among them the team of Abel Bordier, who has an Institute for Replication at the University of Ottawa, who plays a large role in social sciences, that indeed pre-registration plays an important role in reducing false positives. False positives are findings that are declared as true in the literature. This, for instance, this drug tends to reduce certain forms of cancer. So this is sort of a scientific declaration. This is a false positive, to the degree to which it has been published in the literature that there is this association, this efficacy of the drug, which is actually false. Okay, so registration tends to reduce the rate of false positives, misleading findings in the literature. In addition, there is increasing evidence about how the additional suggestions about open data improve the degree to which the scientific studies adhere to high standards of analysis, transparency, and methodology. So the new policies of open data, where each researcher should be publicly revealing their data to the degree possible to the society and to the scientific community to verify, plays a positive role, and there have been some recent studies there. Okay, and in addition, this is an even older literature that shows how problematic is the degree to which publication bias exists, how widespread it is across disciplines, and how important are the limitations of peer review. This is important because peer review is the fundamental cornerstone of modern science. What is considered significant enough, what is considered of sufficient quality in order to be added to the corpus of scientific knowledge. This essentially has been decided using the institution of peer review. Similar researchers decide on the on what should be revealed, on what should be published, what should be added to the corpus of knowledge, and this is the way, this is the safeguard of quality and for science. And in addition, this is also current work we are conducting in Synopsys and in other research groups, examining how incentive structures matter for science, rewarding quantity over quality. For instance, this is an important underlying problem behind the Coara initiative, and how to improve these current incentives is a key challenge. But first, meta research comes forward and shows how these incentive structures reward quantity over quality. So at this stage, let me ask you a little bit whether you have been able to follow the presentation so far, and whether there are any general questions to be addressed.
Are there any questions so far? No.
All right.
No,
There
Professor
will be
Mañan,
more.
thank you.
Very good. No, there
Can
will
you
be
please
more
just, now that we have a small interruption, can you please press this hide in your screen, because we can't see the full picture. Now we have the full picture.
Thank you. So as I hinted before a lot, after the discipline of meta research has matured, one of the most important aspects was to find solutions to these reproducibility problems. Make sure that researchers who start their career now start with the right foot on how to follow best practices, how to conduct reproducible research, how they don't fall into the trap of excessive flexibility, lack of transparency, and the lack of open research, which to a large degree have been at fault for the problems that were substantiated before. So, for instance, here you can see two key platforms where, in a systematic way and with systematic guidance, modern researchers can upload not only their data, but also their research protocols, methodologies, analysis, and code publicly available. So this is a standard practice that many researchers who are inspired by the meta-research movement are following. So in other words, whenever there is a new article, either in the form of final publication or a working paper, it is always accommodated by the link at the Open Science Foundation, OSF, or at GitHub, where all this information is available. And I have to emphasize that with the development of AI, these sort of documentations, which were traditionally considered burdensome and taking time and reducing the potential productivity of researchers, those will be streamlined and much faster to do. So that will be something that technology will do for open science. And I'm very optimistic about that, making all these a standard practice at relatively low cost of time for scientists. So let's go into maybe the most popular approach in experimental science, about how to deal with the problem of non-reproducible research, bias, flexibility of methodology. As I hinted before, this method is pre-registration and accompanied with a pre-analysis plan. Pre-registration essentially says that before conducting an experiment, you publicly reveal that you will do so. You publicly reveal your hypothesis, what you want to examine by this experiment, the sampling process, who are going to be the participants, how they will be chosen, the sample sizes, so all the details about the data generation process. This part is pre-registration, and the pre-analysis plan concerns the specification of the future statistical analysis, data analysis that will be conducted. So currently, as we know so far from meta-research evidence, registration together with a pre-analysis plan is feasible in experimental research again. There is an active discussion, and we are also participating in that. To what degree pre-analysis plans, tying our hands on the statistical analysis we will conduct, whether it can be used to non-experimental empirical analysis, but generally this is difficult because as long as the data have been out there, it is relatively hard to verify, almost impossible to verify that the analysis has not been conducted already and then selectively revealed in a pre-analysis plan, which is not truly a pre-analysis plan, so there are issues of trust there. As long as the data have not been generated yet, this can be quite a substantial improvement. Okay. So one closely related concept that many of our junior researchers here should be very conscious about is the concept of confirmatory from exploratory research. So in other words, when we conduct a new empirical study, we should always start with some theory, some strong theoretical hypothesis. This is called confirmatory research. As long as we do that, we have strong hypotheses, then we can use the usual interpretation of statistical tests, of statistical evidence as testing a hypothesis, providing us with a strong support as long as our significance level is particularly high. In other words, unless this association that we have pre-hypothesized existed, it would be very unlikely that we would have been able to observe this kind of data patterns. Okay, but in order for this whole statistical process to work out, it should be based on clear hypotheses. Okay, if you don't have a hypothesis, but you have a large number of regressions with all sorts of statistical tests being conducted on different domains, and you cherry pick what kind of tests you basically report. This is a pure violation of the principles of statistics, because beforehand you should have hypothesized clearly on the direction of the facts. So, in summary, confirmatory research starts from rigorous theory, rigorous hypothesis, supported by pre-registration, especially. So when you have this kind of findings in the literature, where you have previously clearly made your hypothesis salient and transparent, and the results supported this is confirmatory research. It's much stronger than exploratory research, which is the second category, where you don't have clear evidence. Where you don't have strong hypothesis. So, as I told you before, you conduct very many statistical tests in a given analysis. Some of them show you interesting patterns, but these were not hypothesized. We don't really know why they are happening. But nevertheless, they might be interesting in order to reveal in a scientific article, maybe for future exploration. The important thing is, as young researchers, what should be conscious is to be clear, transparent, and honest regarding which of the results were confirmatory and which were exploratory. This is the key, and currently in research practices, this plays an important role. And of course, I think it should be clear by now that these strategies of p-hacking and hacking that we said before, cherry picking which results to reveal, making a theorization after the results are known, those are going to be ruled out as long as there is pre-registration in it. In practice, for pre-registration, including the Open Science framework, as predicted, the American Economic Association Randomized Controlled Trials Registry, and so on and so forth. So there are several options. And importantly, for starting researchers, there is a guided process in these platforms about how to conduct pre-registration and pre-analysis plans. So to make sure that you can proceed and you have a complete information about your studies. As I mentioned before, in terms of pre-registration, what is clear is the initial research question, how many subjects are going to be chosen and how, inclusion-exclusion criteria, and going further into pre-analysis plan. We will be adding information about the actual analysis that will be conducted, which are the variables that will be measured, how they will be measured, and of course, the specifications of the statistical analysis, which exact tests are going to be used, what will happen in the cases of outliers, and so on and so forth. So this is the new tendency, very strong, and for several domains of research, it's actually increasingly enforceable, which means that for important aspects of the reputation of the researcher, the ability to publish, and so on and so forth, registration plays an important role. So it is important for junior researchers to start utilizing as soon as possible, preferably for the totality of their careers, and of course under the guidance of more senior researchers. Another popular approach is the use of open methods and code. So this is part of the more general movement for open science. So it has been used for a long time for a long time. It has been discussed in the open science movement from the perspective of from the ethical perspective, if you wish, that openness is good. So it is important for all the evidence to be out there. There is no reason to have science results, methodologies hidden and not open to the public. Meta research, after it has come to the front, have shown also the consequences of not having open methods in terms of the credibility crisis. So now the two things have come together. The general philosophical principles, ethical principles of open science for having more openness, and the more practical advantages of open science in terms of increasing the reproducibility of results. So these are sort of more technical details and guidance on open methods. Using modern tools such as Jupyter Notebooks, it is possible to document the processes of the coding methods in much more detail, and oftentimes even in real time, to make everything transparent, to make everything reproducible, to make sure that we know exactly how to reproduce the same results. And it is important to emphasize that oftentimes this seems like an easy process to reproduce using the same code, but it can be very difficult when you do it in practice. From personal experience, these reproducibility checks, when you have been successful in publishing your work in top journals, are increasingly adopted. In other words, the journals come back and say, we are interested in your study, this is good, we will publish it, but we kindly need to conduct a reproducibility check beforehand. Okay? And then oftentimes this process takes months. And when this happens, often differences from the published results to the reproducibility efforts, to the replication efforts, come to the front. In other words, we produce some initial results, we publish them in a paper, we describe them, and sometimes when you want to reproduce them just prior to publication, there are differences, sometimes small, sometimes large. All those issues would be avoided if in the beginning of a research process, open methods and code are implemented. Okay, if from the beginning the protocols are shared, the analysis is publicly available, the workflows are reproducible, these things that are actually now imposed ex post could be available, could be resolved ex ante. Okay, so again, once more, for junior researchers, it's important to start now by being very conscious about the importance of sharing methods and codes publicly in order to get more feedback, in order to get more recognition about their open practices, in order to be prepared for this internal replication process that I just described. And of course, because once more, the cost of these adjustments strongly decrease with the artificial intelligence methods, and I'm optimistic that these things will be very soon mainstream with a fraction of the cost that they used to have. Okay, and of course, oftentimes small differences in the replication process come from different software versions and dependencies, and all of those things will be strongly smoothed out by having the methods and code publicly available. And of course, this will be very important in the process of catching errors, both for the feedback, but most importantly for the process of cleaning our code to make it presentable, understandable to somebody else. That will allow us to catch most of the problems. I will have to apologize at this moment. I would really need to make a small water break. I will be back in 1 minute. Once more, please kindly accept my apologies. Thank you so much for your patience. Apologies for the break. Can I ask you if there are any issues or any questions that might have arisen? Everything good?
All good, Professor Manuel. Thank you.
Okay. So we'll get into the particular problem of open data, which means statistical quantitative information about phenomena in nature codified into data. When can they be publicly revealed? What would be the advantages and disadvantages of doing so? From the perspective of open science, it is clear that this would be a beneficial process to have data as publicly available as possible. At the same time, it should be acknowledged that there are some limitations, oftentimes legal limitations in the revelation of data, depending on how, of course, they were produced. Because obviously data can be used for having financial and otherwise advantages by exclusive exploitation of the data. And therefore, the data is a sort of unique aspect of the of open science that needs to be having special consideration. So some of the ethical considerations that should be minded when we think about open data is the issue of identification. Sometimes we have participants in experiments, for instance, and they should not, of course, be identified. There should not be revelation of private information regarding their behavior in economic experiments, for instance. So it is important to share this data, but in a de-identified way. Of course, an important advantage, an important benefit of open data is sort of clear by our discussion so far. It allows for verification, the reanalysis, and the summary of the overall evidence by means of meta-analysis by pulling data from different studies together. And from the individual perspective of the researcher, if we make our data publicly available, it allows for further analysis, increasing also our citation rates and impact. But this is a domain where the new generations of researchers should be more conscious and know more about the legal issues of it. Okay, issues of privacy, consent, sensitive information, how, from the technical point of view, to use the appropriate repositories, how to make the appropriate rights for the use of the data. So these are aspects that it is clear that the new generations of researchers should be more prepared to take into account. And I think that the more time passes, the education, the scientific education of junior researchers should incorporate these things, making them more mature to the legal issues behind it. So, for instance, when we have a grant application, when we receive funding for our work, we are often asked to have a data management plan which addresses all these considerations, making things as open as possible, but at the same time respecting the legal and ethical aspects, and showing from a technical point of view how it is feasible that you achieve those objectives. So it is important that in the modern development of junior researchers, these things are not learned as our generation empirically when we had only when we had a funding application process, but a modern scientific education makes people more conscious of these concerns earlier. So, to all the issues that we mentioned before, an important role is played from individual incentives. So, why do researchers conduct these problematic practices? Why are they not always transparent? Why don't they always make data openly available when necessary? Why don't they always make code available? Why do they engage in practices such as p-hacking? All of those things can be traced back to the incentive structures of the researchers. What are researchers rewarded for? So going into the question of what they are rewarded for leads us to a deeper understanding of why sometimes science can move astray, can go astray into problematic domains. For a long time, it has been assumed that traditional metrics are rewarding quantity rather than quality. So for people who are not very familiar with research metrics and how research is assessed, In modern times, researchers produce a large number of articles. The difficulty is to assess the quality of the science included in these articles. So what is the quality of research that I have produced in my career in order to reward me for that, to give incentives to do even better research and so on and so forth. It is a very difficult problem to consider, especially if somebody has produced a large number of articles, because of the time necessary to read in depth all those articles and to make strong assessments about them. In most situations, it's very unrealistic to believe that in every assessment scenario, for instance, when I apply for a research position, when I apply for promotion, where I apply for some reward, that the committees will be able to read all of my research. That's where the so-called research metrics play a role. Those are automatic tools that use online material and make a summary of the quality of research that I produce. For instance, H-index impact factor citations. So it's publicly available how many other works, how many other scientific articles have referred to my own work. This is called citation. So with metrics, one can see immediately how many articles that a researcher has, how many citations they have, and other more concrete and more specialized metrics, such as the H-index and the impact factor. So the H-index is an effort to make sure that somebody has a critical mass of important work, at the same time many studies, and at the same time impactful too, rather than having a very large number of works that nobody has ever cited before, or that they have a unique, lucky, if you wish, run that has received thousands of citations, but they haven't really followed up with additional research. Anyway, so these are specific technical metrics, but the problem with them is that they can be gamed. In other words, they are used as proxies to the quality of research. But after they become publicly known, people stop responding in the impassionate manner of just doing my best to produce my research, and then these metrics will be just capturing that. I will be conscious of the metrics beforehand, before I conduct my research, and I will adjust my practices. All of us, basically, will adjust our practices in such a way to be rewarded, to be positively assessed using these metrics. So this is famously captured by the concept that when a measure becomes a target, it ceases to be good. Instead of trying to produce the best possible research, we try to achieve the best possible metrics. So the movement for the responsible use of metrics criticizes specific types of metrics, that they are very shallow, that they don't show a well-rounded picture of a researcher's careers, and therefore, essentially, that they distort incentive for researchers, oftentimes resulting to the problems, the reproducibility problems that we mentioned before. So responsible metrics, it has been argued, must be adjusted for context, specific discipline, career stage, research type, and the way that they should be used is not in a naive way, but in a more sophisticated way, such as using multiple indicators combined with qualitative assessment, and so on and so forth. So from the junior researcher's point of view, these comments have been a little bit above your head, if you wish, because they speak a little bit from the perspective of the research assessors, of established researchers. But when you don't have your research yet, why should you be interested into that as a starting researcher? For instance, I will clarify this now and I will return. You should be ready to present yourselves, to present your work in the form of a new approach, if you wish, which is called the narrative CV. So as you grow in your scientific journey, you will be having a CV that has a fixed form. Most notably, it will have a list of publications. Okay, and then you will have most likely a Scholar Google profile, which will show also your citations. The important thing, and how this should concern junior researchers, is to keep in mind that you should also have at the same time a narrative CV. Generally speaking, how I view a narrative CV is that it describes your research journey. Okay? Every time that you are attracted into a research problem and into an agenda, there is a little bit of a story behind that. Why have you been interested in that research question? And then why were you drawn in the other projects? And so on and so forth. How do you make all of your moves consistent? So essentially, what were your contributions in any given research project? Why were you attracted to that? What do you think you have learned from this exercise in your own personal tone, rather than just presenting a shallow set of bullet points of individual publications? So the narrative CV contextualizes the descriptions, emphasizes quality, emphasizes the personal aspect, the personal contribution within a research project, the exact role in the team, why you were attracted into that, why did you expect this to achieve in terms of societal impact, okay, and other aspects such as mentoring and public engagement. So once more, with the new tools from AI, it is increasingly low cost to produce high quality material, and at the same time, of course, adjust it to your exact personal research journey and prospect and perspective, of how you made your choices, what were your contributions, how do you think are the important implications of your research, and so on and so forth. So again, for junior researchers, you should be already focusing on more qualitative presentations of your work. At the same time, those should be combined with more traditional quantitative metrics. For instance, we have a recent paper where you have three possible candidates that are called by example 1, example 2, and example 3. Instead of just checking if you wish, the number of their citations or the number of their publications, you see a much more nuanced picture using a large number of indices to account for different parts of their productivity, their career, their impact to their discipline, and maybe of possibilities to capture problematic practices. Okay, we don't have enough time into that, but you can see that there are not just one metric, but very many different metrics that can be carefully used, combined with a narrative story, if necessary, in order to really be able to properly assess researchers. So now I will sum up this part by speaking about the Dora and the Koara principles. Those were the key initiatives that argue in favor of responsible research metrics. Okay, so they are closely related to the movements within Europe. For instance, UFA is also one part of them. The effort to be consistent with the principles of these initiatives and declarations. So basically, roughly speaking, they just both of them argue in favor of a more holistic and well-rounded approach in research evaluation, not only shallowly based on quantitative indicators, taking into account of diverse contributions, societal impact, and so on and so forth. Okay, so we have the narrative speech and what should be included, more or less what we discussed before. The specific contributions within a team, the implications of the project, potential methodological innovations, impact, and so on and so forth, as well as team building and mentoring and your role in this engagement. I think we might be running a little bit low in time. How much time do we have left?
5 more minutes.
Okay, great. So I will summarize the discussion with the research identity, integrity aspects. Apologies, and I will leave the last part with the interactive question for interactive session for considering when we share these lecture notes. So another important aspect that the junior researchers should know are all the aspects of research integrity. For instance, when I was conducting my first experiments with human participants, I had to take an online course on the implications of running experiments with human subjects, the ethical principles that should be respected, all the components that should be carefully followed in order to make this consistent with ethical principles and foundations. So you should all be familiar with the core principles of research integrity, such as honesty, objectivity, transparency, accountability, fairness, and respect. Okay? And in particular, when this goes into personal interaction with participants who will generate data for scientific purposes, to this one should argue informed consent, respect for the personality, and respect for the principle of non-harm. So whenever there are interventions with human participants, we should make sure that the benefits that they receive are always graded on the costs. But what should be important, I mean, this shall not be an exclusive list for you. What should be important for senior researchers is to make sure that they address aspects of integrity and within the scientific education at an early stage, which I think still needs to be improved upon. And for junior researchers, to try to get as much information as possible about these aspects to avoid the fact that later on in your research career, you might end up conducting empirical studies or experiments, and you find yourself a little bit immature regarding how to protect ethical principles, and this might complicate things. So it's much more important in the first place from the beginning to be clear about how you design your research in order to respect these principles. So finally, what you should be very careful is to avoid question of research practices. The first category is pure fraud, fabrication of plagiarism. There are very few scientists, practically almost nobody goes into science with the objective of presenting false data. However, this happens not very frequently. But what is much more frequent is what we have been discussing before: p-hacking, hacking, selective reporting, and so on and so forth. These fall into the category of question of research practices. Sometimes one can be also held accountable for problematic practices there. Sometimes it is an issue of gray zone, but especially as young researchers, you should just make sure that you don't do any of those practices. You use pre-registration, you use open science to exclude that you use this kind of problematic practices that previous generations were subject to. Meta-research, this might be the most important contribution of meta-research. It goes to the front and shows how you can avoid doing all those problematic practices. So this is just an example. And I will sum up with this of gray areas and difficult decisions. When is it a decision that must be followed versus one that should be avoided on the basis of ethical principles? How should you deal with outliers? From the one perspective, one number might be very extreme in your data, which make things unrealistic and biased. So it should be removed. On the other hand, if you're dealing with outliers who have not been pre-specified, for instance, in a pre-registration document, there are concerns. To what degree will the removal of outliers be self-serving? So, for instance, when you observe the data with and without the outlier, what kind of temptations will be to have flexibility in what you keep and what you remove? Even when we do use pre-registration, how much MILOOP, what kind of exploratory analysis should we have done before the pre-registration? This is still an open question and a gray area, despite the progress that has been made. Authorship still remains an issue. Who has contributed enough? In some domains, lab managers are part of a publication for everything that is produced within their lab. Should this be the case or not? Again, this is a little bit of a difficult decision. How do you deal with the relationship with your supervisors and funders? This is extremely difficult. What do you do in cases where you see that the practices followed by supervisors might be problematic? This is extremely difficult, especially given the importance of a supervisor in your career and in your development. Then that emphasizes, particularly for junior people, the importance of choosing supervisors in the most mature possible way, and having access to the people who will be able to help in terms of these and these gray areas in terms of research. So I think this is it. We're out of time. There are some interesting particular scenarios that we are considering. This can be left as food for thought for the participants. And these are the key takeaways from today's presentation. It's been a real pleasure. Apologies for not being there and being able to deliver it live. So I don't know if we might have a little bit of time for questions. Thank you.
Thank you very much, Professor Maniavis, for accepting to do it, even though you could not be physically here. Do you have any questions for Professor Maniavis? There's nothing from the online attendees. Okay. We will make sure that we share all your contact details together with your presentation. So later in future, if someone wants to contact you for anything further, they will. Thank you very much for your insight. Thank you very much for being with us, and have a nice day ahead. Thank you.